Solve the cube root of 5a minus 1 equals 4. Again, I'm going to rewrite the equation so that we have a little bit more room to work with it. So we've got the cube root of 5a minus 1 equals 4. In this case, we want to solve for a, and a is inside a cube root, so we need to get rid of that cube root. And the way that we're going to do that is by cubing both sides. The reverse of taking a cube root of something is cubing it. In your subsequent math classes, you might see slightly more precise language for that, but right now we'll just talk about reverses. So on the left-hand side, if we cube that cube root, those operations cancel each other out, and we're just left with the 5a minus 1 from the inside. On the right, we can take 4 and cube it. 4 times 4 times 4 is 64. So we have 5a minus 1 equals 64. Here we will add 1 to both sides. This leaves us with 5a on the left. And on the right, we have 65. Then to get a alone, we divide both sides by 5. And we end up with a equals 13. And because it was a cube root, we don't actually have to check for extraneous solutions. The problems that we run into when we have square roots don't really exist when we're dealing with cube roots. Because when we're taking the square root of something, there are often two possibilities. There's the positive square root and the negative square root. But when we're taking the cube root of something, there's only one cube root of any given number. If we're taking the cube root of a positive number, the cube root is automatically positive. If we're taking the cube root of a negative number, the cube root is automatically negative. So we don't quite run into this same issue. And so when we're solving a radical equation where it's a cube root, we do not have to check for extraneous solutions. Whatever we end up getting is definitely going to be the solution. So here we have a equals 13, and that's our final answer.